Alright guys, we work with Kimley-Horn. I'm Kenny Lombard.
Chase Kemp.
I'm Zach Boyd.
And I'm Madison Rapsis.
Our project was we had to redevelop an elementary school located in Alexandria, Virginia. So it was located in a very urban, suburban area, located between several streets. Our site is actually outlined in that light green color, and you can actually see the previous school on there already. So some basics about the site. It's about 10.25 acres. It is currently zoned RB and POS, which stand for single family, and as you can see, parks, public schools, and open spaces. We actually have residential units along the west and north part of our site that we actually didn't have to worry about. There was an archaeological site actually on there already. It was under the soccer field, and I believe it was an old foundation for a house. However, we didn't have to really take any special precautions with that. And being in a developed area, we had plenty of domestic water and stormwater connections.
We talk about some of the client goals. Of course, it was originally an elementary school, and they wanted a new footprint for the school, which turned out to be an L-shaped school. They wanted new soccer fields, new basketball court, and 20,000 square foot playground. They wanted to have a bus loop that could stack up to 20 buses at one time, and a kiss and ride for at least 10 cars, for the students to get picked up. And then there was a pool on site to the west of the school, and they wanted to leave that whole area, leave the pool remaining. And then for parking, you could join the parking between the pool and the school area. They wanted at least 125 parking spaces, and no more than 70% of the parking spaces could be compact, which was 8 by 16 foot. This is the original layout that we are changing. The school is right there in the middle. You see the archaeological site up in the northwest, and then the pool, which is right here with their parking lot. This is the first design we came up with. We ended up going with the next design, but you see the L-shaped school over there, between the roadway and the soccer field playground and basketball courts to keep kids from running out to the roadway. And then this came up with about 170 parking spaces, and there's actually more of the bigger parking spaces, 9 foot by 18 feet.
So this is our second and chosen layout. The idea behind this design was to reuse the existing parking lot by the pool in order to reduce new asphalt quantities and stormwater structure expenses. The layout also involved connecting the two parking lots in order to create a pass-through for drivers if needed. The parking lot in total has 181 spaces, which is a lot more than the client requested, and we ended up reducing this amount later on in our design. We placed the kiss and ride close enough to the school entrance, as well as the basketball court, playground, and pool as well. As you can see, our final design hasn't changed much from the design before, except for the addition of parking lot islands in order to increase green space. And since we already had enough parking spaces, it didn't matter that much. We also widened the kiss and ride in order to incorporate a passing lane. And the existing site had a grade that sloped down from the northeast corner to the southwest. So we basically tried to keep that the same in this design. The parking lot was sloped south and west, 2% in each direction. And we decided to split the school into 2 finished floor elevations, since the school's length is basically from property line to property line. It would be difficult to tie in contours to off-site properties otherwise. We actually did run into problems with this. North of the site, we had problems with this north of the site, and to resolve these issues, we added a retaining wall north of the parking lot and north of the school. We also ran into some sloping problems next to the building between the soccer field and the school. And so we created depressions leading to inlets in order to solve this. We had 10 proposed inlets on our site. This figure shows the land cover of each one, except for the gray areas, which the area on the bottom left The stormwater landing there would be covered by existing stormwater structures. And the gray area on the right is mostly green space, but the stormwater landing there would be caught by the street system. We also added a swale between the pool and the playground in order to catch more stormwater runoff there, and then led it to a culvert that bypasses the sidewalk into a proposed inlet.
For our stormwater pipes, we ended up using 1 foot reinforced concrete pipes. That was calculated using the rational method. Our peak flows, as you can see, increased by about a factor of 2, so which wasn't too bad. We were then able to calculate the amount of water we would have to retain due to this increase, which came out to about 0.6 acre feet. In order to deal with this, we were using cast pipes, which are corrugated aluminized steel pipes. In the north parking lot, we had to use 2 of those at a 96-inch diameter, located on a 0.1% slope. This allowed us to effectively delay the water. And underneath the bus loop, we had 1 cast pipe, same slope, same size, which caught all the water that landed on the east side of the school. And here are the drawings for that. The rightmost drawing shows the east side of the school with our stormwater pipes going around and landing into the cast pipe on the bottom. These 2 drawings on the side, the top one is for the north parking lot, and the bottom one is actually also the bus loop as well. The other side of it with our other inlets.
All right, for sanitary sewer, we had 3 cleanouts, points from our school that we had connected to, starting with up north. So the first one, we connected them with 8-inch PVC pipes all the way down until the last cleanout, which then we went to 10 inches. And that connected to a 12-inch combination sewer that was in the roadway to the east. And the average velocity is about 3.5 feet per second, and we kept all these pipes at a 1% slope.
For our water lines, they were actually on the west side of the school. We had a incoming water line that was already there, which was 4 inches of ductile iron pipe. We were able to run that same size pipe up along the school, and you can see the beginnings of the kiss and ride, our handicap parking, and our main entrance. The pipe actually went farther than that before reaching a tie-in, and we calculated the flow we would need based on the 800 students and about 115 faculty members. Their needs, including a peak factor of 4, gave us a peak flow of about 4,500 gallons per minute. This water line was also continued up to reach a fire hydrant on the very north part of our site, and there was also another fire hydrant next to the soccer field, which would be on the east side of the site.
So for the erosion and sediment control plan, we basically decided that 3 construction entrances, one on the east, south, and north sides would be required. And we had 3 diversion dikes leading to 3 different sediment traps. And we had a silt fence along the eastern and southern sides. And we only decided we were going to keep 4 existing inlets, and we will need protection for those. And we were going to be stockpiling on the new soccer field and basketball court. So as you can see here, we have the construction entrances on each side, and then we have the silt fences along the south towards the east side, right past the sediment trap extending northwards, and we have a diversion dike from this sediment trap going northwards, and then a final diversion dike between the 2 sediment traps on the west side. So we decided that only one of the entrances was going to be made temporary, and that was the eastern one, just because coming from Cameron Street from the south, we needed an entrance to the Kiss and Ride, and from the north side from Boyle Street, we needed another entrance to the north parking lot. And we needed temporary seating for the soccer field, playground, basketball areas, and the diversion dikes and sediment traps are going to be kept until the final grade. And once construction was finished, it was actually placed in a perfect position. We didn't need to adjust any of them. In addition, we need to have protection for the last 10 inlets, and 2 temporary slope drains were added for the building space, and they're located right there. Any questions?
Can you guys give just an example or two of some difficulties that you may have run into during urban redevelopment projects?
Well, there was the grading we had, making sure that with the finished floor elevation and that tying into the north part, I know we had a lot of difficulty with that.
Yeah, grading is the biggest issue because you have to tie into the grades of the properties that are very close to the site that we developed.
There are also issues with stormwater, making sure that none of the stormwater from our site would run off into a neighbor's or surrounding site, making sure that all of our stormwater always went to the same place.
Can you explain why you transitioned from an 8-inch sanitary sewer line to a 10-inch?
We had the third clean out coming in, and it just added volume.
You actually had that much flow that it required 10?
The velocity was actually also too high. It was something like 20 feet per second, something unreasonable, which would worn through that pipe in no time. And by increasing the diameter of the pipe, we found that we could actually drop that velocity to something that would actually, or that wasn't destructive to the pipe.
Any other questions?
Did you guys say there was combined sewer you're tying into?
Yeah, it was an old combination sewer, and our instructor, they said that they're actually phasing that out, but it used to combine the sanitary sewer and I think the stormwater. They combine it, but they're phasing out the stormwater part. It's just an old way they used to use it.
So they have to redesign this when they phase that out?
Probably just knock off the connection, but yeah.
What was the final cost of your project?
Like 1.2 million.
Could you explain the use of that cast pipe again?
The cast pipe was used to slow down the water time. It's just a big metal pipe that sits underground. And as far as I know, it's just on a very slight slope, which basically retains the water longer than it normally would in a standard pipe.
Pretty much, we didn't have enough space above ground for a detention basin, and it's just meant to hold underwater. It's basically an underground detention basin.